Hello everybody, this is Mr. Basil, and let's get to it. So, in this video we're talking about Learning Target 5.3, which is all about the parts of different kinds of chemical reactions. So, by the end of this video, let me go ahead and move myself here. Your goal is to identify parts of a chemical equation and draw particle diagrams to represent atoms in a chemical reaction. So let's get started with just some definitions here, things that you probably already know, but I do want to just draw your attention to. So subscripts are the small numbers listed after or to the right of elements in an equation. Okay, so small numbers listed after the elements in an equation. These tell you how many things there are immediately to the left. Okay, so in this equation right here, this would be a subscript, this would be a subscript, and this would be a subscript as well. This 2 tells me that I have 2 nitrogens. This 2 tells me I have 2 hydrogens. This 3 tells me I only have 3 hydrogens. I don't write a 1 there, but you can imagine that there's a 1 there. That 3 would not apply to the nitrogen, because the nitrogen, there's only 1 of them in this molecule. If I were to put parentheses here, then this 3 would apply to everything that's in here, in which case I would have 3 nitrogens and 3 hydrogens in one molecule. But that's not the case. I only have the 1 hydrogen that this 3 applies to. So there we go. Then we have coefficients. So coefficients are the large numbers listed before a molecule. Okay, before or to the left of a molecule, and these apply. These apply to the whole molecule. Okay. So this is a coefficient. And again, there's not a written 1 there, but we can imagine that that would be the coefficient if we were to write it. And again, that applies to everything that comes afterwards. So this right here tells me that there are 3 H2 molecules. Okay, this tells me that there are 2 NH3 molecules. All right. Yeah. So let's see what that looks like. So let me just start drawing some pictures here, and I think that will help you visualize a little bit of what's going on here. If you already know, we've already covered this a little bit in class as I've taught this. So go ahead and try to pause the video and see if you can come up with the particle diagrams by yourself, and then check to see if you have the right answers here. I'm going to sneeze. Okay, sneeze is done. But again, pause the video, see if you can do this on your own, and I'm going to show the answer here in just a moment. All right, so if you're not quite sure how to do this, just go ahead and follow along with this one, and then try yourself the next time. So this right here is just an N with an N. I only have 1 N in 2 here because, again, there's no coefficient, so we say that there's 1 and 2. And this 2 again is telling me, hey, I've got 2 ends that I'm drawing there. Then this one, in one molecule, it's H and H. But that 3, that coefficient of a 3, tells me I have 3 sets of those. So I would have something that looks like this. Okay? I've got 3 total sets of H2 molecules. If you want, you can certainly come in here and put that plus sign here, just to remind yourself that those, that, I don't know, some people like to do that, so you can feel free to do that as well. And then let's go over to the product side now, and we have in one molecule, there's 1 N and 3 H's. Again, this little 3 tells me I have 3 H's, and that does not apply to the N. But this coefficient of a 2 right here tells me that 2 here tells me I need 2 sets of those. So let me just go like this. And that. And there we go. The one thing that I did not label yet, so that's your particle diagram. The other thing you need to know is that these are the reactants. And then over here, these are your products. Okay. And the reactants are what are there before, then they rearrange each other, and they collide, and they break bonds and form new bonds, and they make the products. The one thing I don't have in here is, like, what does G, L, AQ, and S mean? So these will sometimes be listed like after the after that, and that just tells you the state of matter: gas, liquid, aqueous, and solid. All right. So now the rest of these, pause, and then I'm just going to show the answer. So the next 2 are just kind of like practice problems or examples. So go ahead and pause the video, and I'm not going to walk through this one as much in detail. I'm just going to show you the answer. Alright, and there we have it. So in this one, this little 4 tells me I have 4 hydrogens, so I put 4 hydrogens on this 1 carbon. There's no coefficient, so there's only 1 molecule. Over here, I have 4 Cl2s, so in 1 molecule I have a Cl, 2 Cls. That's what the little 2 tells me. And then the big 4 tells me I have 4 sets of those. Notice how they're all separate. I should not have them all clumped together. Then I've got my arrow sign to show me that I'm going to products. These are rearranged, the reactants rearranged to make my products. And here I've got 1 Cl4, one CCl4. So 1 carbon and 4 chlorines, and only 1 group. And then the coefficient of a 4 in front of the HCl tells me I need 4 sets of HCl. So I kind of mixed this one up a little bit, didn't have them all oriented in the same way, but it's the right idea because I've got 4 different groups of HCl. And it doesn't matter the way I have that shown there. Alright, one last one. Go ahead, pause, try this one on your own, and then I'll show you the answer here when you're ready for it. Alright, this one was a little bit trickier, a little bit more drawing, but same idea. So C3H8, we've got 3 carbons, 1, 2, 3, then 8 hydrogens, 1, 2, 3, 4, 5, 6, 7, 8. And I only have 1 group of those because it doesn't have a coefficient. Over here, the 5 O2s, I got 1, 2, 3, 4, 5 sets of O2s. This little 2 tells me in one molecule, I've got 2 oxygens. Now these collide, they rearrange, they break bonds, they form new ones. See, I've got 3 carbons here, I've got 3 carbons over there. So these are just colliding to rearrange to make something new. So I've got 4 H2Os, 1, 2, 3, 4. And in each molecule, I've got 2 hydrogens and 1 oxygen. 3 CO2s, so 1, 2, 3 of those. And then in each molecule, I've got 2 oxygens and 1 carbon. And then the thing that I'll just leave you on, because this is the last example, count how many total atoms you have before and after. That should always be the same if this is showing the conservation of mass properly. So 1, 2, 3, 4, 5, 6, 7, 8 hydrogens on the left. 1, 2, 3, 4, 5, 6, 7, 8 hydrogens on the right. if you do that for all of the different elements in the compound, or in this reaction, that should be true as well. All right, thanks for watching, and see you next time.